Hi, everybody. I'm Tad Hunt, and today we're going to be talking about optimizing file storage for your use case. If you are hoping to learn about something else, like maybe block or persistent disk, you're in the wrong place. So I'm the product manager for File in Google Cloud. I'm actually a file system geek. Before Google, I built a file system company, and I've been working on File for about 10 years now. In my spare time, I'm a rock climber. Anyone else do kind of any extreme sports? Nice, nice. I can't see most people. All right. This is up in Yosemite. Pretty cool. Our agenda today is we're going to cover kind of an intro about the file storage options in Google Cloud. And then we're going to deep dive into 3 managed services that we provide: Google's Cloud File Store, Elastifile's Cloud File Service, and NetApp's Cloud Volumes. So just to be clear, what are we covering today? What are we covering? Object, block. That's somebody else. Hopefully you've gone to some of those interesting sessions as well. We're going to talk about file. So where do I store my data? In this taxonomy of storage systems, we generally break it down into some structured, which is databases, and unstructured storage systems like file, block, and object. This is the file bit. The key takeaway here is that GCP has lots of storage options, whether you have structured or unstructured storage needs. We basically have all the things, which is good for you and good for us. All right. So let's dive into some file use cases really quickly here. This is not the complete set of use cases. There's lots of ways to slice and dice file. We're going to talk about them in these categories: general purpose NAS, some high performance computing stuff, some hybrid cloud stuff, backup and archive and NAS gateway, scalable caching, and CSP storage, which we have a new name for this cloud services platform. Anyone remember the name from the keynote? Anthos. All right. Good, good. Cool. So we all know that file workloads are incredibly varied. And our first-party offering, which is File Store here on the top left, it won't always be the best choice. And for that reason, we're committed to supporting a strong partner ecosystem. We have some of our partners up here to present and talk about their offerings. Meeting customers where you are often means providing the same tools that you're already using on-prem, or that have the advanced feature set that you might need. Our partners complement File Store with things like scale-out performance, rich and deep feature sets with well-established histories, support for hybrid cloud and container storage, the ability to stitch together lots of distributed storage sites, and many more. This is possible because we believe that a strong third-party partner ecosystem actually recruits the best expertise across the industry to solve your problems that any one of us isn't going to be able to solve all of together by ourselves. Right, so together, the end result is you get the best solution for your problem. We're not obviously going to cover all of these use cases today, or the myriad other use cases that there might be, but we are going to cover a couple of really cool, exciting examples, I think. So if you are crazy excited about file and you just can't get enough, we've got a lot more storage sessions about file. I'm not going to read these. Feel free to take a picture or look them up later. We're going to cover some of the workloads in the sweet spots for File Store, NetApp, and Elastifile, but these are a small fraction of file workloads. Google is actually ready to solve a lot more of your file storage needs. I think, in my opinion, we're the best cloud for that these days. We've also got talks specifically covering rendering, hybrid cloud, and HPC. And so feel free to jump in on those. You'll have to pick between rendering or hybrid. So if you need to do some hybrid rendering, you got to split your time between those. All right, let's talk about File Store, and then we're going to dive into Elastifile and NetApp following. So today, I'm actually super excited to announce Cloud File Store's general availability. It launched actually today. So there'll be a big blog post going out tomorrow with this. So the 2 main differences between beta and GA is we have increased the performance, which I'll show you in just a minute. And we've added an SLA. So now we have a 3 nines SLA. It's live in production now. If you check out the website, all the docs are updated. You can see all of the info. So anyone in the audience, I can barely see you, but anyone in the audience using File Store today? 1, 2, 3. There's a bunch of you. All right. So NFS and shared file systems are like the arteries of many enterprise workloads. And in a way, enterprise is doubling down in a big way, enterprise is doubling down on GCP and hybrid cloud, in part because now it's mature and it can actually run a lot of these enterprise workloads the long tail of enterprise workloads that you might have. With file store now generally available, and the rich set of partners we'll talk about a bit later, you can make the choice to lift and shift your apps rather than rewriting to object or database. And so this actually helps ease your migration to cloud. Feedback during beta has been generally overwhelmingly positive, and we have actually got PayPal up here to talk about some of the observations they've made during our beta program. So we're going to talk about detailed use cases. Like at a high level, let's say that file store in the general purpose workload, it's unblocks small to mid-scale compute clusters and enterprise applications that need access to shared file systems. Let's see. All right, so Jason, put your hand up. Everybody give mad props to Jason. He's an engineer on the file store team. So him and the whole rest of the team have made this possible. I just get to talk about it. All right, and if you have any technical questions afterwards, catch him before he runs away. Cool. So here's a couple of maybe the top 5 file store use cases that we're seeing from our beta program. What's file store good at? Well, obviously a lot more than this, but some of the key workloads we've already tuned file store for are rendering, application migrations, the sort of the long tail of enterprise apps, web content management, media processing, and dev and test environments. I'm not going to dive into any of these right now. The really exciting thing is PayPal's going to do a really deep dive into dev test. I think you'll be really excited, and it's pretty interesting. What's one key thing that all of these and probably all of your file workloads rely on? Well, probably performance. So we're actually pleased to announce with GA, we've increased performance sequential read on premium instances to 1.2 gigabytes per second. And we've increased random read IOPS from 30,000 to 60,000. So these are actually pretty significant performance increases. And if you've been playing with the beta, these actually rolled out midway through our beta. And so you actually get to take advantage of this with no change in price or anything. So this is actually super exciting. So we didn't just make file store fast. We actually made it really easy to reason about the performance you get. If you're price sensitive, pick standard. And in which case, your performance varies a little bit based on capacity. If you are performance sensitive, pick premium. Your performance doesn't vary no matter what scale, and you're not paying per IOP. You're just paying dollars per gig per month, and it's a fixed flat fee. And in fact, you pre-provision your capacity, and so right up front, I'm going to spend this many dollars on storage. And so it's actually pretty cool. In terms of your pricing and predicting your pricing, it's great. Let's talk quickly about features. This is kind of an eye chart, so I'm not going to spend a lot of time here. But at a high level, you can configure shares up to about 64 terabytes. Premium and standard have different minimum sizes, so that we can guarantee the performance. One of the really exciting thing is because you have to pre-provision your size. Not only do you know how much you're going to pay at the end of the month, but you can actually grow it online. And we have stack driver metrics and alerts which can automatically fire and do things like webhooks to automatically grow the size, should you want to do that. So you can get a page if you're going to exceed the capacity you think you should pay for as well. We are at about 500 active clients out of about 5,000 connected. That's kind of a small render farm or a small batch workload, or even maybe a mid-size batch workload. We're a zonal service with high availability, with 3 nines SLA, and typical recovery time, when we need to reboot for a software upgrade or we detect an issue, is typically under 120 seconds, which is within the NFS timeout. From a networking perspective, everything is super secure. We're RFC 1918 private IP addresses, and you can access it, cross zone and cross region, but not from the public internet. Anyone ever put an NFS server on the public internet? I've done it. Don't do it. It's not a good idea. So you can't even do that if you wanted to in Google Cloud, which is great. And like all Google products, we're super secure. We think security is really important. And so we have encryption at rest and in transit, according to the rest of the platform. So there's some details and some white papers that we've released there. Integrations. We were integrated with a lot of the main things that you're going to use in GCP, like particularly Compute Engine, GCE, and Kubernetes Engine, GKE. On Compute Engine, I especially want to call out we're integrated not only with regular VMs but also preemptible. VMs. So this is really great for your batch compute workloads. And Kubernetes engine in GKE, we're integrated with the CSI driver, and so you can actually dynamically provision file store instances. Speaking about dynamically provisioning, there's 2 ways to do that as well. You can go to you can go to the console and which is the GUI. You can do it via API, or you can use our command line. But you can also use it through Deployment Manager, which is our native offering, and also Terraform. I think the Terraform team tells me something like 10 or 15% of file store configurations are done through Terraform, in fact, which is pretty cool. So we worked with the HashiCorp to put our integration in there. Cool. Now we're a storage product, and so backups, we're more traditional, right, rather than object storage kind of, which is cloud native. So backups are a thing. We're integrated with both Actifio and Commvault, which are 2 of the leading third-party backup vendors. Anyone using any of these? Actifio or Commvault already? Yeah, these are pretty common. A couple of people. All right, and just to kind of wrap up this section, file store is available in almost all GCP regions. There's probably 3 or 4 regions which we're not deployed in yet due to some capacity constraints for us, but that'll happen later this year. And it's in GA. It's GA in all of these regions right now. All right, so that's the quick run through for file store. We'll have time for questions at the end if you have kind of any specific questions, or you can hit me up or any other presenters. Right now, I'm paid to tell you file store is great, so you probably shouldn't believe me entirely. I think you should, but maybe not entirely. So let's fix that. Please join me in welcoming Dinesh Madavin. I probably said his name wrong. I only have American phonemes. The senior software engineer at PayPal. He's going to tell us all about the PayPal development team's journey from completely on-premise into completely cloud-based development and test.
Thank you, Ted. Hi, everyone. I'm Dinesh Madavin. I've been a senior software engineer at PayPal, doing mostly developer experience like SEM, Jenkins, and deploys. So let's get into what PayPal does. So this is our PayPal journey to cloud. We began way back in 2014 with the decision to containerize everything, and we tried a lot of stuff. While much of it was useful and made developers' life easier, the developer experience team increasingly struggled with growing the scale and complexity of managing these systems. This led us to directly to the decision to migrate everything to cloud so that Google could carry out the burden of keeping the infrastructure healthy, and we could focus on developer experience rather than the infrastructure. To put this in some context, in 2013, we started the journey with 1 monolithic Jenkins with hundreds of plugins and more than 40,000 jobs running on a DL980. And this got better after we migrated to OpenStack, and we used Mesos, Marathon, and Docker from 2014 to 2016. And by 2018, we were creating so many jobs that we were not able to scale, so we had to it was a pain to stand up our own infrastructure, which was a bottleneck for all developers. So we started migrating to Google Cloud. In 2018, we started migrating all our dev and test to cloud, which has enabled us to scale to more than 12 million jobs per year. We are truly scalable now, and this was a huge win for us. And in 2019, we are planning to migrate our mobile SDLC also and use file store for more use cases at PayPal. So to understand why file store is important to us, I need to describe our development architecture and scale. We'll start with that and then dive into where file store helps us out. We were early adopters of file store. We were amongst the very first customer when it launched in beta back in July 2018, which means that we can also cover our experience with file source reliability and availability during that time. Finally, I'll wrap up by talking about what we are going to do next and what kind of platform we are giving to our developers. So this is our architecture. PayPal's developer experience is centralized around a continuous integration and continuous deployment pipeline built on top of Jenkins, the leading open source automation server, Mesos, Aurora, Zookeeper, MongoDB, and Nginx. When developer commits their code, a build is automatically kicked off, a unit test are run, and the Docker image that is built is deployed to a server, and all the functional tests are completed, and it's automatically approved to be pushed to production. And this basically happens everything in Jenkins core, Jenkins master. That is the core of our development architecture. So we make sure each development team is not blocked by any other team by providing one Jenkins master for every team that's there. We also use Mesos to orchestrate our Jenkins master and slaves, which enables us to manage our fleet of GC VMs as a single pool of resources that we can scale up and down on demand. Above this, we also provide a continuous integration API, which encapsulates our CI/CD functionality. Our Aurora framework schedules the long-running process and our cron jobs. File store here provides persistent storage for our Jenkins masters. We are able to scale the number of file store instances sublinearly with respect to the number of Jenkins masters, which is not just a testament to the file store's performance, but also helps with manageability because there are less resources to keep track of. So before file store, each Jenkins master also included the CI data. This means that the backup has to back up all the CI data that was inside the Jenkins master container. You can recall that we were well on our way to 5,000 Jenkins master containers. And as you can imagine, this was a huge scalability issue for us. And also, it was not as reliable as we wanted to be. And all the data that was in the CI, we were backing up to GCS and learned that encryption, compression, and network latency is not your friend. So during this era of rapid growth, we were in never-ending cycle of container failures and also data loss, and leading to a poor and unproductive developer experience. So we stepped back and looked for alternative solutions. Naturally, we thought that making the containers stateless is the way to go. And FileStore was launching beta at the same time, and it turned out that this was exactly what we needed to refactor the statefulness out. So let's talk about use case with FileStore. So what we did was we were backing up everything in our containers, and it was the containers was going out of memory. So we completely removed the process of backing up and restoring from inside the container, and we moved all our data to the file store. And we were able to scale our containers to more than 5,000, and we were putting it on file store instances mounted on multiple VMs. And because we moved our architecture to the file store, we were able to completely get rid of the container backups. And after moving to the new process, we were able to start up our containers from, which was taking many hours, sometimes 3 to 4 hours, to less than a minute, which was a huge win for us. So you can recall from my earlier comments that we were being file store customers since beta launch, and we have seen the service go from where we weren't sure we could run in production to a point where we are pleased with its reliability and availability. When we migrated file store last year, our metrics tracked multiple outages, which sometimes lasted more than 10 minutes. And this caused our workloads to freeze and the developments to stall. This means that all of PayPal could not run any builds or any deploys, and everything was frozen. We worked closely with the file store team on these issues. And over the last 6 months, we have not seen one issue where file store exceeded SLA. And this was not even officially GA yet, so which is a good thing. This significantly reduced our support costs, which is a fancy way of putting that I'm not getting paged anymore. So the most important outcome of this thing is our developers are no longer experiencing productivity loss due to the CI/CD system being down. So moving forward, we are looking at more performance-intensive workloads and to run our builds also on the file store. Currently, we are using a local SSD exported. We don't expect network-attached storage to be quite as fast as the local, but we think that it's fast enough, and the performance trade-off is worth this simplification to build the slave environment. We have just begun looking into the restructuring our Android and iOS mobile build and test, and we think that we'll also get the similar level of maintainability and scalability out of file store. Thanks for listening, everyone. That's what's up at PayPal, and I'll call Tab back and hand it off.
Thanks, Dinesh. Cool, that was great. You know, it's not every day that a development organization the size of PayPal's makes such a large sweeping change in a migration like this. So it's pretty exciting to have them part of the file store beta and to help make file store, the strong product that it is now in terms of its SLA and features. If you have questions about this or anything else as we go along, Dinesh and everyone else will be available for Q&A at the end. And he'll be around the conference, I think, a little bit more as well. So if you run into him, definitely get the inside scoop. Next up, we're going to talk about Elastifile's recently launched cloud file service. So I'd like to introduce Allon Cohen and Devin Lehman from Elastifile and Google, respectively. Come on up.
Awesome. Thanks, Dad. So bridging off of Tad's rock climbing photo, I wanted to show that I'm a snowboarder who's lucky enough to work at Google, but I didn't have any snowboarding photos handy, so that's a photo of me jumping out of a perfectly good airplane. And for my day job, I'm an engineering program manager on GCP, who's responsible for working with our technology partners like Elastifile. And so I'm up here with my colleague, Allon Cohen.
Thank you, Devin. So this is a before picture. The after picture isn't as pretty. We'll be introducing to you the Elastifile file service, and thank you. So Elastifile offers a fully managed file storage as a service inside Google Cloud. We're POSIX compliant, which means that you can move enterprise workloads such as SAP directly to the cloud without the need for refactoring. We are scalable, and this is one of our key differentiators, and we'll show you this shortly in the demo as well. Because we're software defined, essentially you can dynamically grow us and shrink us upon need, and you're charged by the minute. When you use more, you pay as much as you use. When you don't need it anymore, you can just shrink it down or close it up altogether. We provide enterprise feature sets such as HA, snapshots, dedupe, compression, so we really can migrate and move to working the way you worked on-prem, even as you migrate into the cloud. And we are cloud native as a software offering. We appear in any region, in any zone, and can even offer the service across zones. Anywhere where Google provides infrastructure, we can provide our file service. We are fully integrated into the Google environment, including both on-prem and the new, including both cloud and the new on-prem offerings. And you can get our billing through Google Billing and access us through Google UI. You don't need to believe me because I'll give it back to Devin. We will demonstrate it for you.
Great, thanks, Allon. So if we could switch over to my laptop, that'd be great. This would be kind of awkward. I have to type and use the hand mic. But what I'm going to show you today is, bridging off what Allon said, how easy it is to find, enable, and then create an Elastifile cluster, all from the GCP console. So if you've ever used GCP before, you're going to see it's the exact same look and feel from deploying anything like cloud storage. I get a tile, clearly says Elastifile. There's syntax branding Elastifile, but it's all powered by Elastifile's backend. I hit manage. It brings me into the product page, at which you're going to see cluster details. So no need to run scripts, no need for authorization or authentication protocols. I just hit create. And within the product page, I get standard syntax you'd expect. So file name, I can call it test. Next, region deployment, and this is super important. I want to talk about this for a second. So Elastifile's managed file service is deployed holistically on GCP. So similar to FileStore, any region where we have PD and compute and the corresponding software for Elastifile, you can deploy this cluster easily and also then mount your client from that region. So if I want to do something like US Central 1 and select the particular zone, I can do that, or select regional and Elastifile managed service will do it for you. You have the ability to then select the service class, which you expect high performance general use or something else, and then you can see underneath here estimated total. This is really great because you can see how much the cost association is going to be. This is an estimate, but you know at the end of the month what you'd be expecting to use subject to that particular service class, and then you can select allocated capacity. All this is dynamic. Sliders will change. It's a really easy way to see what this cost is going to be. From here, you can do authorized networks. So this is where you set up your VPC peering network, either local or shared. I've got a couple before that I can select. But if you haven't done it, from the UI, prompts will show up. You copy it, you throw it in your terminal. It's up and running in no time, and you don't have to do anything outside of the console. There's a couple advanced options we can show you as well. So if you're restricting client access or opening up client access, you have the ability to create read-write rules or delete read-write rules that exist, and then enable straight snapshots straight from the UI. So all one page, all easily. I'm going to hit cancel just to give you a quick view of what it looks like on the main page. And then you have the ability, kind of similar to what we were talking about before, but logging into Stackdriver to get advanced analytics and metrics. So if you want to have logs data, I can select any one of my existing instances, and it'll redirect me within the console to see what's going on. But if I want to log out to Stackdriver and set up alerting or reporting, we have that functionality too. Super quick demo. Come talk to us afterwards, and we'll give you a more robust one. But I want to pass the mic back over to Allon so that he can show you what this looks like to scale out Elastifile Cloud File Store.
Thank you, Devin. So we did want to show you a bit of this in action. So if we can switch back to the other computer. What we're going to show you is essentially a demo of an HPC workload. We'll do this in 3 arenas. On the top right, you see the performance coming from the Elastifile system. On the bottom right, you see the Google console showing you the VMs that we're spinning up. And on the left, you actually see orchestration. We are fully accessible via API, and in this case, we're using Slurm to automate the bring up of 1,000 VMs. These are preemptible VMs, which is another great reason to use a file service. You can save a lot by using the preemptible VMs. If someone falls, no issue. You have persistent storage as a service. You spin up another VM through the orchestration, and that VM will access the data. We've just spun up 1,000 of these VMs through orchestration. And what I want you to follow is a bit of the throughput that we are achieving and the connections. We're actually using 2 NFS mounts for each one of those VMs. So you can see the count of connections rising up right now at 1,300, growing up to those 2,000 connections for those 2,000 VMs. And the throughput we're running now is upward of 2.4 gigabytes per second. This is not the limit, but in terms of cost, even though we're using preemptible VMs, we didn't want to go much beyond 1,000. You see now a tail there of workloads, and that's actually the orchestration system bringing up additional VMs, which were preempted earlier. So if you needed to complete the project, no problem, through the automations, even though Google infrastructure took one of your VMs, they're simply spun back up and used. As Devin said, come ask us afterwards any questions. And we also have a booth here, which we can show you further demos. Thank you. Back to you, Tad.
Cool. Thank you, Allon and Devin. That was a really exciting demo. Anyone ever see in anyone's cloud kind of scaling up to that many gigabytes per second of throughput that quickly? That was pretty awesome. So next up, we're going to have Niraj from NetApp give us a talk about Cloud Volumes, their new Cloud Volume service from NetApp. So please join me in welcoming Niraj.
Thanks a lot for being here.
Come on this side.
Yeah, just get that on. Thank you, Tad. Good afternoon, everyone. I'm Niraj Verma, Technical Marketing Engineer here at NetApp. I recently joined our Cloud Data Services business unit. I focus solely on Cloud Volume Service for GCP, and I'm very interested in listening to what you have to say on what you see today, the demo, as well as the product. I work very closely with the product manager. I'd love to bring back some feedback or questions that you may have. Clicker. With that, just to frame the conversation, we'll spend just maybe 5 minutes on this one slide, and then I'll go into a basic demo of the UI. And then after that, I'll show you another demo of an application use case where we go through some of the features of the product. So we'll first define the service. What is NetApp Cloud Volume Service? The simplest way to think of it is that it is an NFS or an SMB endpoint in Google Cloud. And as far as the features and some of the benefits that you get for your applications, your system design, and your users, first we have the standard file interfaces that you can deploy. You have your NFS for your Unix applications and SMB for your Windows applications. And one thing to point out here is that NetApp has been a pioneer and a leader in the shared file space for over 2 decades now. And we bring that experience and, more importantly, the stability of our technology to Google Cloud. Next, sorry, I should have mentioned I'm going from top left down. Second, we have the fully managed service tenant where we don't want you to be in the business of standing up this infrastructure, underlying infrastructure even one time. So right when you deploy your application from the get-go, you have this available for you to quickly spin up and mount on your application without having to then even worry about the life cycle of that application when it comes to patching or scaling the storage that it's using. Multiple performance levels. The service comes in 3 flavors: standard, premium, and extreme. Each of these 3 flavors have a performance metric associated with it, and I'll show you more of that in the demo. But think of it as the 2-dimensional service, capacity and performance, and you get it in 3 different flavors: standard, premium, and extreme. The fourth thing on the bottom left, rich data management. This for us is a key differentiator. We not only allow you to quickly spin up endpoints for your application, but we also think about the lifecycle of that endpoint when it comes to protecting your data, as well as creating rapid copies for your application lifecycle, going from dev to test, staging on your pathway to production. Moving to the top right, native service experience. Now, experience was a key design goal for us when we started working on this service. And you'll see in the demo next, in the basic UI demo, that what I mean by that, you don't have to go outside the Google ecosystem in your application storage journey. When it comes to support, again, as I mentioned, experience was not just from a look and feel standpoint. We also wanted to think about your journey as an engineer, as an architect, as a DevOps engineer. When it comes to support, we know that things are going to break and you're going to need some help. So what we've done here is that we allow you to talk to your same Google ecosystem for your level 1 support. And NetApp will work with you on the back end for L2 and L3 escalation cases as needed. And billing is also integrated. We don't want you to manage a second contract or second piece of paper. You get the same bill that you get from Google with the line item for NetApp based on the performance service level that you choose. And being a true cloud service, we also allow you to pay for what you use on an hourly basis as you go. With that, I'll move over to my laptop for a quick UI demo. All right. So as you can see here, I'm currently logged into the Google console, and I'm currently in the API library page, and I can simply type NetApp here. And it brings up the NetApp Cloud Volume Service API. Since I already have it enabled, I can then click on Manage, and this brings me into the dashboard for Cloud Volume Service. Listed here are some volumes that I created in the US East 4 region, way too many of them. You can see quickly the name, all the key detail that you need just to get a quick snapshot of your state, the region, lifecycle, if it's available and mounted, service level, the mount path, capacity, and the protocol that you're using. On the left, you see this tab right here, the volume, and then you also have a snapshot tab, which I'll talk about in a second here. And then you have the 80 connections tab for your SMB volume creation. So I'm going to go and click Create. And here you can see that I have 2 options, NFS and SMB. I'm going to give it a name here real quick. Pay attention to how much time it takes for me to go from here till the volume creation, and I'll tell you why. So once I give it a name, I have the path automatically chosen for me. You can change it, but make sure if you change it, it's unique across the entire project. Speaking of service level, here they are, 3 service levels with the performance that you can expect from each of them. If you stop by the NetApp booth, I can demonstrate the performance aspect of these 3 live over there. But for now, I'm going to choose US East 4 region. This tab right here, Snapshot. Now, this allows you to create an on-demand. This allows you to create a volume, just like we are, from a snapshot that you previously created of another volume from that tab on the top left. We're not doing that in this case, so I'll skip that. We're creating a new volume, so I'll give it a minimum size of 1 terabyte. And then you have your standard NFS export policy permissioning. I'm going to add a rule to open all. I'm very generous with my security. So I open it to all clients, and then I can choose read and write. And with that done, last thing I'll mention here before I click Save is I can then now also take snapshots in an automated fashion where I can then set my schedule. hourly, daily, weekly, minutes, and also my retention. I'm not doing that in this case. I'll click Save. As I mentioned, pay attention. I clicked Save, and it takes me a couple seconds. So we actually, you didn't hear this from me. We have a contest going on in a booth. If you do this, and if you do it the fastest, then you'll get a Bose wireless headset. You didn't hear this from me again. Right now, I think the clock is about 25 seconds, and I think you can easily beat that. This is the basic demo. I'm not going to mount this volume to an instance, but I'll show you if you wanted to do that. You can quickly click on this icon right here, and you can check out your mount instruction. Simply copy and paste that in your Linux SSH session, and you'll be able to do that. Now, with this basic demo coming to a conclusion, I'm going to switch over to an application demo. I've kept this application demo simple. What I have here is a Google Cloud instance, compute instance, which I call Confluence Next Demo. And in the next screen, I have a cloud volume from NetApp, also called Confluence Next Data. And what I'm doing is I'm installing Confluence. This is an application example of an enterprise content management system where you're sharing and collaborating files. So I install that app on that Google instance, and then I switch the directory for data to that cloud volume I just created. The app is installed. Now what I'll do is I'll fire it up. I'll create a new workspace, call it DevOps, and then I'll add some data, couple of web pages and some pictures, just to show you production state. You have some data running on your application. Once this is done, what I'm going to try to depict here is that now you have data and application running on cloud volumes in Google, and you're, let's say, in production, right? And maybe you have a business need. You want to make some changes to your steady state, and you want to maybe do an upgrade or add some, or maybe move this copy of your entire application to another environment, let's say PT or something, right? So what you can then do is you can take an on-demand snapshot that I showed you in the UI demo earlier. You do that by clicking on that top left snapshot icon, or you can edit the volume. Once you take the snapshot, the nice thing is that then you can clone this snapshot and create a new volume from that snapshot. This volume that's being created is now going to be also resized in the process, so you can change it from 1 terabyte to 2 terabytes. Now you mount it back to your Confluence instance, and you'll notice that I'll change the directory for the data, and I'll still have all of my web pages and the data that I created in the previous step. Got a bit ahead of myself. There it is. So the new data volume was mounted, and I have my data. At the same time, I'm also migrating my application from version 6.1 to the latest version of this app. And I can do that now because I'm confident that if anything goes wrong, I can go back to that point in time copy of the snapshot that I created. That's the demo. Thank you. Can I switch back to the PowerPoint? Next slide. I should do that. Okay, so just on a closing note, the service is currently in paid alpha, so you have to be whitelisted in order to access the service, but that's changing next month when we go to beta release. A couple of new features that are coming out with beta. We'll be exposing our API. So now you can take that API and programmatically access cloud volumes with other Google technologies and provision that from your Google Cloud command line tools. And the other cool feature that's coming out in beta is that we'll be automating the entire process of whitelisting and onboarding, so you can now, in a self-service fashion, access the service. It's open to all, basically, next month. And from a regional standpoint, currently we are available in Central 1 and US East 4 regions, but we'll be adding US West 1, which is LA, and EU West 2, which is, I believe is Frankfurt, in the summer time frame. And then following that would be London and Sydney. I think I'll stop with that, Tad. So thank you all for listening, and back to you.
Great. Awesome demo. Thanks, Niraj. Cool. So that was a great demo of some key enterprise collaboration workflow on GCP and, of course, the UI for the Cloud Volume Service. So this is at the wrap-up section, so I'm just going to summarize what we covered. We covered cloud file stores, ability to do some general purpose NAS, and kind of drilled down into the dev test area. We looked at Elastifile's GKE and preemptible VM story for large scale. And we looked at NetApp's enterprise content management. So I think the really cool thing here is you see 3 different managed services, all built on GCP. And while we talked about at our keynote this morning, the open source services platform, right, and bringing open source in, we're actually doing the same thing, and we've really prototyped that with these industry partners as well. So of course, there's a lot more workloads that all of our partners in FileStore can do. Right, so please check out, these folks' websites, some of the other sessions we talked about, and everything else out there. The key takeaway here is, if you walk away with only one thing, is Google Cloud is actually, very ready for your enterprise workloads. Bring them on.